Let's now take care of the collisions, and we will need a collision for our base that's going to be underneath our primary simulated chunks, and also we will need a collision object for the terrain that's outside of the simulated area. So let's go all the way back, and we will maybe arrange all of these nodes in a second. Maybe I will grab all of these, which are our main fracturing, and place this a little bit below, and we want to go all the way back to our geo init, and here we separated this surface portion of the terrain, so this chunk over here, and we were left with this geo base. So we want to use this as a collision object. So let's go ahead and also assemble this. I'll drop down on assemble here, turn on create packed primitives, and for this assemble I will leave this create name attribute on because we don't really have a name set up prior to this node. And also, just to be sure that we maintain original names, I will just rename this output prefix here to base. Okay, so we should have, if we go to our geometry spreadsheet, a name that's going to be base 0. Okay, and I will Control C to copy this node and go back to my .NET. Let's step inside. Let's drop down a static object, and let's place our subpath to point to our geobase. Okay, so we can preview this here. And I want to set up a simple collision, so I will just drop down this into a merge, and let's combine this with our stream. Preview the output, and now we should have both of these imported. So if I press play, this should now work, and we can see that it's going to collide with our base, and the base will be a static object, so it won't move, it will stay as it is. So we really don't have to worry about anything else. The problem here is that if we go to preview our static object, and maybe for clarity I will rename this to base, or maybe let's rename this to collision or base collision. Okay, so just to be extra clear about this. If I go to my collisions tab over here, we can see exactly what's going to happen. So in the bullet data tab, which is what's going to be seen by this rigid body solver, if we turn on show guide geometry, we can see that by default this operation will turn the geometry into a convex hull. And if I take a look at the geometry that's being simulated, which is the blue one, and turn this off, we can see that all of this surface here in the middle, it's not really being accurately represented by this collision geometry. So one way we can fix this is if we also split up this entire geometry into multiple pieces that then become this convex hull geometry. So let's go back up a level. Let's go to the first frame, and let's go all the way up to our geobase. And so from this wire I want to scatter some points, and I will drop down a scatter node. And I only want to scatter points on the surface. And so for the group here I can select our back group, which we created earlier, and I want to scatter maybe 35 points. So now we can use these points as cell points inside a Voronoi fracture. So let's drop down a Voronoi fracture node, plug our split output into the first input here, and the scatter into our second input, and let's preview this. And let's also create a visualizer. And we can see that these are going to be the resulting pieces. So from over here with these pieces we can do the same thing that we did earlier, is we can drop down a convex decomposition and make sure that these are all convex hulls and simulation friendly. And this is also how the geometry is roughly going to look inside the simulation. So the simulation basically creates this kind of convex hull automatically when we simulate using bullet. And if I duplicate this node and plug this into our second input, and if I set this max concavity maybe to 10, we can see that this is how the geometry originally would be simulated as, so as this big convex hull, as opposed to this over here, which we maintain some of this detail here from the original geometry. Okay, so let's get rid of this. And let's place this assemble node after our convex decomposition. Okay, and this now becomes my geobase. So going back to our .NET simulation, let's go back inside. And there's still something we have to do here. So if I turn on show guide geometry, we see that we still have the same problem. And that is because we have to turn on this create convex hull per set of connected primitives option on. So now we will have a much more accurate representation of the geometry base. So we can turn this off and go to our output. And the final thing that we have to add here is going to be our collision with the exterior of the surface.